The inverse operation of a derivative is the antiderivative, also known as the integral. And if you have x to the nth, this is the answer to the integral antiderivative of x to the nth, which we wrote right here. And when you say antiderivative of x to the nth, this is how we write it. We write this symbol and put this dx after it. Not going to go into why you have all those things right now. There's more behind it I can't say just as an intro. So when I say this, I'm saying what's the antiderivative of x to the nth, or the integral of x to the nth. And this is how you find the answer. You take the power, you add 1 to the power, and divide by that new found power, and then add a constant. Now, since they're inverse operations, the derivative of this would take you back to that. So let me show you that. If I take the derivative of this, it should take you back to x to the nth. And watch it. It works. So the derivative of x to the n plus 1 would be n plus 1 in front. Leave the x. You have the n plus 1 here, but when it's you minus 1 from it. Don't forget the n plus 1 on the bottom. Okay, that stays there. And then what is the derivative of a constant? The derivative of a constant would be plus what? It would be nothing. So we don't need it. Derivative constant's gone. Boo, 0. All right, now watch this. Don't these drop out? Doesn't that create 0? So doesn't this whole thing all become x to the nth? All right, so a constant drops out, and all of this breaks down to this original. So the derivative of this takes you back to the function. That's what an inverse does. An inverse, when you do an operation to do it, it takes it back to where you started. If you think about other inverse operations, would be you have x squared, its inverse is the square root of x. Because when you square root this, you get this. When you square this, you get this. There are many inverse operations, like add and subtract are inverse operations. So the integral is the inverse operation of the derivative. So when you take them, they go back and forth between each other. So let's use this formula to take the integral of this. Just like derivatives, you teach each piece one by one. So let's take the integral of each piece one by one. And what we get here is, well, we leave the 3 in front, and we're going to add a power, okay, to squared, and we're going to divide by the 3. All right? Minus, leave the 8 in front. There's a 1 hiding right there. Not hiding, but just we don't mark it. So add 1, add to 1, you get a 2, and divide by that power. And then remember here, this is really like x to the 0, if you want to think about that. So we have 6. This would be x to the first divided by 1. All right. So if we clean all that up, don't these disappear, leaving you x to the third. You know what I just forgot? Plus c. That darn plus c is so easy to forget. All right, next. 8 divided by 2 gives you a negative 4 x squared. And then x to the first divided by 1 is just x, so this is plus 6. And I'm not going to forget c this time. This would be the antiderivative, or the integral, of this original function. All right, we're going to take the derivative of this function right here, and then take the antiderivative of it, and we're going to see, what do we notice? All right, so let's take the derivative of this first. Okay, that would be g prime x is equal to 3x squared minus 10x. Now we're going to take the integral of it, or antiderivative. So we're going to put that right here. You put a dx on it, little weird notation. All right. Now let's take the antiderivative using our formula. Well, that leave the 3 out front. This would be x to the third over 3 minus 10. This would be x to the second over 2. And don't forget plus c. All right. And what we get here is these disappear, leaving you x to the third. And then this leaves you minus 5x squared plus a constant. So what do we notice here? Well, if we take the derivative of this and then integrate it, don't we get back to itself? And we notice there's this plus c. What does that mean, the plus c? Well, if I had any number added to this, would I get back to it as well. Like at a plus 2, plus 3, you would notice why there's a plus c here. Because when you take a derivative back, it could be any number there. This situation, the c is 0. So the c is a little tricky. We're not going to go too much in depth, but what I really want you to notice is when you take a derivative and then take its integral, you get back to where you started.